Okay, so our first lesson today, we're going to be looking at comparing rates of change of functions and looking at average rates of change. So our introduction question for today this morning was to consider the depth or the height of the water in this vase as water is poured in at a constant rate over time. So what's going to happen is it's going to start off and there'll be no water in it. So clearly we have to start off at this point here. Our first point has to come from here. When time is 0, there's going to be no water in it, and the depth of the water, or the height of the water, is going to be 0. The water is going to increase the depth is going to increase over time, so the graph is going to go up. It's going to be increasing all of the time. But the rate at which it increases is going to vary. So if we look at the diameter of this vase here, it's going to change. So to begin with, the diameter is at its greatest, so the depth is going to change slowest. The depth is going to change fastest at this point here. So at this point here, where the vase is narrow, it's going to be going up more and more quickly. So this one is going to come up, it's going to come up slowly to begin with, like this one. And then it's going to go up faster and faster. It's going to slow down a little bit in the last section, and then it's going to stay constant because it's full. No matter how much more water you add to it, it's going to continue at this rate. Okay, have a go at this question and trying to determine which is the correct answer. If you have trouble reading from some parts of the classroom, you can have the notes open on the Google Classroom to help you read. I prefer computers closed where possible, which is why I prefer people to sit here at the front. Okay, so as the water is poured into this over time, the height is only going to go up and up and up. So it has to go up all of the time. It can't be C because that goes down at one point. The height goes down. So it's always going to go up. Because the shape of the vase changes, then that means the rate at which the height changes is going to vary. It's going to be not constant. This would be a straight-sided vase for this one. So then the last thing to look at is when is it going to be increasing slowest? When is the rate of increase going to be slowest? And it's going to be here. So somewhere in the middle of the time period, it's going to slow down. So D, we can see here in the middle of the time period, it fills quickly and it fills less quickly in the middle and it starts to fill quickly again. So it has to be D. Okay, so this is the key information for today's lesson. It lets us discuss and consider different possibilities. So firstly, here in this one, when we look at increasing or decreasing functions, we have a definition from a function's perspective of what it means to be increasing. So a function is increasing if for two values where a is less than b, then f of a is less than f of b. So if we take any 2 points, you take this point here, you take this point here, you look at the x and the y value. If this is a and this is b, then if the y value of b is bigger than the y value of a, the function is increasing over that interval. And here is the definition for decreasing.
So is this APPC?
It was, but we're halfway through class now.
So I was fixing my schedule.
All right. So our key information for today's lesson is this bit here. This is going to be quite new to you. Maybe we aren't familiar with what these words mean, concave up and concave down. If we consider a function, it's got like a smiley face to it like this, we can see that the function is concave up. If it's got a sad face to it here, we say that the function is concave down. Now the way that we use this information, and this is what needs to be memorized on this one, is if we're trying to determine whether the rate of change is increasing or the rate of change is decreasing, we can look at the concavity. It's the quickest and easiest way. So if the function is concave up, the rate of change is increasing. If the rate of change is decreasing, that will make the function concave down. So this will work in both directions. So if we go back to that last question here, so if we look at this, we can see that the rate of change to begin with will go down. It will decrease the rate of change. then the rate of change will increase. It will get faster and faster. So if the rate of change is decreasing, that means it's going to be concave down, and then it's going to be concave up. So concave down, and then concave up. You can see it in this graph. You see here, this is concave down, this is concave up. You can see it on this one. Okay, have a go at this question. Just for the person next to you if you need. 1 minute for this.
So is this similar to GCSE math?
Sorry?
Is it similar to GCSE math?
Foundational or regular level?
Regular.
Yeah, you need to be getting GCSE math. You need to be getting a 6 or higher to be prepared for this course.
Okay.
Otherwise, you'll struggle. The kids that had a 4 that joined the course, they quit.
But do you know if we learned this in GCSE math or no? Or is it going to be something?
Most of what we do will be new, but connecting to the we've just covered what it means to be increasing and decreasing. So apply the knowledge that we've just looked at to this new situation.
Thank you.
Okay, did I pause this time or not? No. So on this one, we can see that the function is going to be increasing on this interval here and this interval here. So in order to write the answers for those ones, we need an increasing interval, which is going to be from -2, no, I'm sorry, 0. Going to be from 0 to 3, and it is also going to be increasing from 7 to 9. Have a go at this question? 1 minute.
So what's the code for Google Classroom?
I'll share that later. I'm working with other things at the moment. If you'd arrived on time, you'd have had it.
Circulate over the AC, please. Make it colder. Very hot. Take your jumper off.
The AC is 2 degrees lower than the temperature in the room.
What does that mean?
It means the AC is not working properly, it's not catching up with the necessary heat, it's trying to cool the room, but removing the jumper will be a quick solution for it. Okay, let's have a look at our solution here on this one. So what we're looking at here in the question is it tells us that T1 is at F and T2 is at G, so we're interested in this part of the curve here. We're interested in these values here. So firstly, on the interval, which of the following is true? Is it positive or is it negative? Well, we can see this function here. If we look at the y values at these points, we can see that the function is always positive between these 2 points. So we know it's going to be one of A or B. It's going to be positive. Is the function increasing or decreasing on this interval? Well, it's going down. It starts off at 4 and it ends at 0, so it's decreasing. This has to be the correct answer. Describe how the rate of change is changing. Okay, so this is our key knowledge again from today. It's about the concavity. Is the function on this interval concave up or concave down?
Down.
It's concave down. So that's our reasoning. We have to start by giving our reasoning. The function is concave down on this interval. This implies, does this imply that the rate of change is increasing or decreasing?
Decreasing.
Decreasing. This implies the rate of change is decreasing. Have a go at this question. Give you a couple of minutes for this one. All right, let's have a look at these ones. So, what do we do? In the diagram, the graph of the function k on the interval 0 to 9, we've got 6 points. On which of the following is k negative and decreasing? So first we have to look from A to B. A to B, the function is negative, but it's rising. So I'm just going to go along crossing these up. This one is this one here is negative, but rising. From B to C is positive. No, so it's positive. D to E, it's negative, yep, and decreasing, yes. Let's just check the last one. The last one is E to F, it's negative, but it is increasing. So the correct answer through logical deduction is C. Which of the following statements about the rate of change is true? So let's just read what it's saying. It says the rate of change is decreasing, the rate of change is increasing, decreasing. All right. So it's looking at whether it is increasing or decreasing. So that means we want to know whether it is concave up or concave down. So this first one says the rate of change is decreasing. Does that mean the function needs to be concave up or concave down? Explain to the person next to you. So this statement here, the rate of change is decreasing, implies that it should be concave down from A to B. This is concave up. This is concave up. Notice here, this is concave up. So it's not going to be A. In B, let's do both of the concave ups. Let's see D. D should also be a concave up. E to F. This one's true, isn't it? This is concave up here. So the decreasing, both of these two are concave up, and they should be concave down. So on these next two, the rate of change is going to be increasing. So if the rate of change is increasing, are we looking for concave up or concave down this time? We're looking for concave up. B to C, that's concave down. So it's not that one. D to E, that's concave up. So the correct answer here has to be C again. So what the most important thing from today's lesson is this association between the idea of concave up means the rate of change is increasing. Concave down means the rate of change is decreasing. Use that knowledge. It's new, it comes up a lot. Okay, so have a go at this question here. Okay, so we're told here in the question that at point A here, there is a change of concavity. That means the function goes from concave down to concave up. a point at which there is a change in concavity like this one has a specific name. We will be calling this an inflection point. So where a function moves from concave down to concave up, or vice versa, we will get an inflection point. It says there's only one inflection point in this graph, so that means there's only one change in concavity. On what interval is the function decreasing and the graph concave up? So the function is going to be, let me highlight those two areas. So if we're looking for on what interval the function is decreasing, the function is decreasing from here to here. Like this. If we also look at the same time on when it is concave up, it's concave up from here to here. So in these two intervals, it's going to be decreasing and concave up. We need both. So the two intervals overlap in the period from -1 to +1. From there to there. Now, I had a quick go at these questions before class today, and I got the next one wrong. I just noticed it as I was doing it again. And this is quite common. So in the wording of this next question, you have to be quite careful. Are we talking about the function, or are we talking about the rate of change? I interpret it from, I was thinking about the function. So when it talks about, on the interval, the rate of change is positive and decreasing. So the rate of change is positive. What does that mean that the function is doing? No. So let me just answer your question. So we can't quite interpret that from that one. If the rate of change is positive, that means the function is going up. We can't determine anything about the concavity from that part of the statement. It's insufficient information. So for instance, looking at the function here, it's concave up here, concave down there, but the rate of change is increasing in both intervals. You with me? On what interval is the rate of change positive? So the rate of change being positive means the function is going up. So let me just clean the graph a little bit. What you're going to find very quickly with the questioning strategies that we have on this one is the wording. This course is not great for a second language learner. This course can be, these sort of AP courses, they are far more precise on the mathematical terminology and the English used than other math courses. So you need to be very, very tight with what it's saying and very quickly and easily misinterpret it and get the wrong answer. So on what interval is the rate, sorry, did I start recording again? Yes. On what interval is the rate of change positive? So the rate of change positive means the function goes up. So the rate of change is positive, the function goes up. On what interval is the rate of change positive? Now the second part, the rate of change is decreasing. So the rate of change decreasing, this part of the sentence. So the rate of change decreasing means we can look at the concavity. So do we want concave up or concave down?
Down.
Both.
Well, half of you are right. So if the rate of change is decreasing, then it's going to be concave up. It's going to be concave up. If the rate of change is decreasing, it's going to be concave up. So which of the two green intervals is concave up? Well, this is the section that's concave up. So it's going to be from 1 to 5. It's going to be from 1 to 5. The rate of change is positive, means it's going up. The rate of change is decreasing, meaning it's concave. Oh, wait, sorry. backwards through that. I got that slightly wrong there. All right, we're right up to here. So the rate of change is decreasing, means it's concave down. Means it's concave down. The rate of change is, let me write it on the board. Rate of change is decreasing. Implies concave down. I don't know if you've noticed, but when I'm considering the rate of change, whether it's concave up or concave down, obviously when I'm teaching, I'm thinking about a bunch of other things, and when I'm sitting doing math on my own, I'm really focused. But just to make sure I don't make a mistake, you might notice that I look over at this poster. I've got a poster up there to help me. So just so I don't quite say the wrong thing, I'm like, oop, just double check I'm not messing up. So the rate of change is decreasing, means it's concave down. So putting that onto our graph now, if we want the rate of change to be decreasing, we need to be concave down. We need this section here, so our interval this time means we go from -5 and up to -3. Okay, have a go with this. Have a go with this question. Need a minute for this one, quite easy. Sorry? No. Okay, let's have a look at this solution here. I haven't posted. Okay, so this time we're looking at average rate of change. You should have covered average rate of change in grade 9, in Algebra 1 or in IM2. We do average rate of change there. So the average rate of change is going to be from 2 to 3. So if we look at x equals 2, that's this point here. And we look at x equals 3, that's here. And then we draw a little line across. What the average rate of change here is nothing. On average, there's been no change in this interval. So the average rate of change looks at the difference between the two endpoints. It looks at the difference between the two endpoints. So here in this one is going to be 0. From 3 to 5. So from 3 to 5, we're going to go from there down to here. So it's going to look like this. Is the rate of change on this interval positive or negative?
Negative.
Negative. So that's less than 0, isn't it? So here we can see it's negative. From 5 to 7. From 5 to 7, 7 is there. We are going up on this one. So this one is positive. This is our best so far. And then from 7 to 8. From 7 to 8 we're going, again, that's horizontal from 7 to 8. So there's no change there. This one is 0. So the only positive value is going to be C. This has to be the greatest average rate of change. Take out your calculators here for this one. I will show you how to do this one on your calculator.
Do you know how to test code?
So what we've told here is you should have seen this formula before. You should have seen this formula before in grade 8 and 9, average rate of change, or even just the gradient formula. You should recognize this one. So what we need to do is we need to calculate the average rate of change on the interval 2 to 4 for this function. And we're going to use the calculator for this one. So the thing I recommend first, following along with it in your hands, press on. This will allow you to create a new page. You can press 1 on the keyboard here for a new one, and then you can say no to saving it. Whenever you open up a new document, always add a calculator page, like this.
So what do you mean document?
This is a document.
For a calculator?
Hold up your calculator.
Because
This calculator is not suitable for this course. The recommended calculator for the course is the TI Inspire here for this. In fact, for all math courses here at this school, you're expected to have a TI Inspire. Minimum requirement is a graphing calculator. A scientific calculator is not suitable for higher level math.
So nobody told us up until now.
You are now told. You have a week, get one. Okay. So we are going to add a new page to the document. So Control, Add Page. Look where I'm pressing here. Control, Add Page. And we're going to choose number 2. We're going to add a graph page, number 2. This lets us type in the function. So open up your graph page like this one. Type in the function as we see it here. We've got x squared minus, then we need the quotient symbol. Quickest way to get the quotient symbol like this one is Control Divide. We get the quotient symbol. You can also find it under the templates button here next to the I. Next to the 9. And we want 1 over x. Put your hands up if you need some help. I'll just hop around quickly. It's one that is only available to teachers. It's a teaching resource. You need to get a...
This is okay, this is not separate.
No.
Is it like this?
You can go to GeoGebra.
Are you doing a book on scheme? Are you doing Then I have interest engineering.
That's why we did this step explanation. Exactly what I did. Cool. Control and
I need to take the course I don't take like math. Because if I don't take the grade 10,
Are we doing over here?
just like
You can press enter on that one.
in grade 12, I want to do the rest of AP stat, and in grade 12, I don't
Almost. Alright, let's have a look.
So I'm just taking
Put your phone away. If I see your phone out during class again, you get a detention. Okay, so now you can press, to move back to the quickest way to move back to the previous page is to press Control left. And you'll change pages. It's quicker than using the touchpad here, using the keyboards. So what we need to do, we need to use this formula to find the average rate of change. We need f of 4 minus f of 2 all over 4 minus 2. Because we have the 4 and the 2 given here. We need to type this in. So, we're going to press Control and divide again. We get the quotient symbol. This button here where it says variables, find it on my screen, find it on your keyboard above the 9, the variables button. If we click the variables button, it lets us pull up F1, the function we just entered. We can do F1 of 4, scroll across, minus, and we repeat that, F1 of 2. So from 4 to 2, that was written there. And then we can do 4 minus 2 here on the bottom. And then press enter. Here is our answer. So I'm just checking that I got the answer right. 1 minus, yep, I seem to get it right. 49 over 8. So this is 49 over 8. If your calculator gives you a fraction like this one, for some reason you fancy having a decimal, just press Control Enter and it will convert it into a decimal. 6.125. For an AP exam, for all AP exams, standard decimal approximations of an exact answer should always be given to 3 decimal places. Okay? 3 decimal places. You can round to 3 decimal places or give the exact answer. So the exact answer for this one is 49 over 8. Also, 6.125 is an exact answer for this one. But if there were more and it was rounding and cutting it off, 3 decimal places is the standard for this AP course.
We have a problem with the calculator. When we put that in, it said like.
I'll set up the next question. I'll come over and check it.
Is it not like 3 significant figures?
No, that's IB. IB is 3 significant figures, so we tend to do 3 significant. Most of our grade 9 and 10 courses are guiding you towards the IB. We do 3 significant figures there as well. But the AP does 3 decimal places, which leads to some stupid answers. If you've got an answer which is in the tens of thousands, decimal places aren't really important at that particular point, but that's how we do it. Okay, so let's go on and have a go at the next question. Have a go at this one. It's a bit more algebraic. I'll come over and help down on that calculator. Can you open it? This is a non-calculator question, obviously. Did you define?
Shall I replace some of the video and show you me explaining it very clearly and saying find this button, pointing to it? Please watch carefully what I do. You want to put the function.
So what is this?
Use that calculator as an expression to do that. So we do.
What did you get, John? Excellent. Where's your work? It would be good to see you setting up the f of a minus f of 0 or a minus 0 first, before you come to the correct answer. Okay. And it might be also good to start off saying average rate of change equals.
No, this
Yeah. Okay, so we want average rate of change equals, and we're going to need f of a. Oh, sorry, it's not f, is it? This function is given as g, so we need g of a minus g of 0. This is all over a minus 0. So let's put a into the function, and we're going to get a squared plus 3a plus 1 minus, and then g of 0. We can calculate that one quite easily. If we put 0 in here, that's going to disappear. Both of these two terms will be left with 1. So g of 0 is 1. So if we subtract g of 0, we're subtracting 1. This is therefore going to be over a. 1 minus 1, they cancel. And we are left with a squared plus 3a over a. And then next we can simplify. This a cancels these ones. We're left with the answer of a plus 3. Chat.
Yeah, so you use like the previous formula to do this question.
That's not.
You have to memorize it.
Yes. One of the difficult things about this course is there is no formula sheet. All formulas must be memorized. And once you get into the trigonometrical angle identities, there's a lot. Yeah. So all formulas must be memorized on this course. You'll also find yourself memorizing a few key phrases for reasonings. So if you, some questions will ask you to explain why this is, why the function is, the rate of change of the function is increasing. And you'll be memorizing phrases such as, the function is concave up on this interval, which implies that the rate of change is increasing. The formulas, yeah, you must know that. If you come late to class, you have no bathroom rights. Next time. We've only got 20 minutes. Will do. Yes. All right, this is our last one. This is an exam-style question. You would have 2 minutes for this, so let's try this now. You have 2 minutes for this question. I'll put a timer on for this one. These easier ones would usually take you about a minute, so you can save your time for other questions. I'll allow you to discuss with the person next to you if you wish. What did you Good. Go to the Google Classroom. Start the homework. Make sure you write it neat enough that I can.
Yeah.
Okay, you have 1 minute left. No. One of the great things about this course is most of the, 2/3 of the questions are multiple choice.
If it is multiple choice,
Yep. For homework questions with multiple choice, it's nice to give a little bit of reason. But listen, can I just say with homework questions for multiple choice, it's good to show your solution. Because usually with multiple choice questions, this one is generally going to be doing this one in your head. You're going to be doing this one in your head. But a lot of the multiple choice questions, you actually have to calculate the average rate of change by hand. For homework, I expect you to show you're working and then decide. In an exam, you get a lot of scrap paper. So you'll write your solution on scrap paper, but then you'll just click on the computer and you will do it in a website, and you'll say A.
So our work's not graded
In
in the exams.
the exams, for multiple choice, your working is never graded. For homework, your working is graded. For FRQs, free response questions, which is a third of the exam, your working is graded. Okay, and we'll learn that along the way. I don't have my posters up yet, but we do, I can't remember, actually I can't remember how many of these there is. I think it's 42 multiple choice questions without a calculator, 28 with, and then you have 4 free response questions that take an hour.
4 questions for an hour.
Yeah, it's
But there's like multiple parts.
multiple parts, multiple parts.
You just need to explain.
Yeah, you have to show your working. You have to show your working, and some of them you have to give reasons. And you know, what we would have from today would be the function, the rate of change is decreasing because in this interval the graph is concave back, and things like that. And those are the type of reasons. All right, let's have a look at this question. You'll start to see it a little bit more as we dig in. I'll show you over the next couple of weeks how things are going to look. Today we're just getting started. This is an exam style question that's going to look exactly like that. They can be quite wordy on these ones. So what you basically got is you've got this toy car moving around and around. It's going to start off at here. So we are looking at what is the distance from this wall to the toy car. So at the starting point, it's got to be 0. It's got to be 0 at the starting point. So the graph has to start off at 0. All of these match that. The distance is going to become further and further away, and then it's going to come back to 0 again. So it's got to be positive. The distance always has to be positive, and it has to never go negative. It's got to move further away, and it's got to come back to 0. So it can't be this, because it has to go further away, come back to 0, and then go further away again. It can't be this. It's got to come back to 0. Got to come back to 0. So it has to be one of these two. These two are very similar, these two graphs. And the main thing is looking at how will the distance change. So in this first part of the circle, the distance is only going to increase very, very slightly. In this section of the circle, it's going to increase very, very quickly. So it's going to go slow and then fast, slow again. So it's this one. And you'll get more familiar with it. A circle, any kind of circular motion like this one, such as a planet moving around another planet, a moon moving around a planet, or the effects of tidal shift due to the gravitational pull of the moon. It's always going to lead to a sinusoidal function like this one. We will study these functions in detail in Unit 3. This is Unit 3, second semester. Although we can read the graph and interpret it at this particular point to see what the average rate of change is. All right, that's the lecture finished for today. Let's have a look at some housekeeping now.